Okay, so just kidding. We're going to turn part 2 into 2 parts. So now this is part 3. My phone decided that it was full. So anyway, it stopped at a fairly decent time. So we calculated g of alpha, where alpha is our variable, and this is a good place to stop for that because that's pretty simplified. So now we need to plug in g of alpha into our equation for the function f of x, something that is a little better than this. So I'm going to write it on the side so I can store it for later use. So g of alpha equals 1 over alpha times pi. Actually, you know what? We're going to write 1 over pi and bring alpha in. And then we have sine alpha pi over alpha minus sine alpha pi over 2 also over alpha. And that, within parentheses, is our equation for g of alpha. Yay! So I'm going to erase this, and now we get to find f of x. Cool. So this is number 2. F of x equals the integral from negative infinity to infinity of g of alpha times e to the I alpha x. Oh my gosh, I said x and I wrote pi. That's great. E to the I alpha x, and then this integral is taken with respect to d alpha. And now we plug in g of alpha. So we get negative infinity to infinity of 1 over pi, that can come out because that is a constant, of sine alpha pi over alpha minus sine alpha pi over 2 over alpha times e to the I alpha x d alpha. Still writing crooked. That's okay. All right, so, oops, I forgot parenthesis there. Okay, so now, let's see. What we could do is I look at my notes and I double check. So honestly, this is called the Exponential Fourier Transforms. So if you wanted to be like, cool, I'm done, this would actually be an acceptable answer. I am also going to double check that I got that right. Yes, so sine alpha pi minus, so this term is negative, cool. So this would, you could be like, cool, I'm done, we're good. But if you wanted to simplify it a little bit further, you could also do that. If you're taking a test and you have time, your teacher will appreciate that. If you're in the real world, I shouldn't say that, school is whatever. Anyway, if you're working for a company or you're doing your own project, it might be easier to simplify a little bit more, but this is a valid formula for f of x, and you could be like, I'm done. We're good. We just did a lot of math, and walk away. But if you want to simplify it further, let's do that. So what we would do is we would use Euler's formula to write this out and then use the even odd shenanigans that we learned in part 1 to simplify a little bit more. So what we're going to do is that. So 1 over pi, negative infinity to infinity, sine alpha pi minus sine alpha pi over 2 all over alpha times cosine of alpha x minus I sine alpha x, boom, and then d alpha. Okay, so now recall that sine of alpha over alpha is going to be an even function. That is hilariously crooked when I look on the screen. Anyway, okay, hopefully you can still read that even though it's super crooked. Okay, so sine of alpha over alpha is even. Pi is a constant, so that doesn't change the format, it just scales it. It doesn't change the shape, I should say. So these are both are going to be even functions. Cosine is an even function, sine is an odd function. So even times odd is going to give me odd. Oh, look at that. So when we multiply all these terms out, either of these terms multiplied by this term over the interval from negative infinity to infinity is going to all go to 0. So that's great, because then I can be like, ha, you're going to go to 0 when I multiply you with either of these functions. So that allows us to simplify to 1 over pi, negative infinity to infinity. Maybe I can like write this not crooked. We'll see. Okay. Sine of alpha pi minus sine of alpha pi over 2 over alpha times, oh no, still crooked, times cosine of alpha x times d alpha. And that's pretty much it. Since it's hilariously crooked, I am going to, well, yeah, let's just, you know what? We're just going to do that. Okay. Because we already canceled it. D alpha. And then the one thing that we have left to do is we can be like, oh, look at that. These are all going to be even functions. So we don't have to go all the way to negative infinity. We just multiply the interval from 0 to infinity by 2. So we have a 2 out front, and my 2 is a little funky looking, so I'm going to rewrite that. And that's it. Ta-da! So now you have something that's a little bit simpler. To actually evaluate this integral, you would just multiply these two terms by cosine. What's nice is that you have one less term to deal with, and that can be a lot easier. Cool. Yeah, so I'm going to double check that I did that right, that I'm not leading you astray. Let's say 2 over pi. Yep, cool. We are all good. So now we have a simplified equation for f of x. You could stop here, and that's the exponential Fourier transform, or you could go a little bit further and get to here, which is going to be slightly easier to evaluate for a given value of x, I suppose, because you still have an x over here. But yeah, now you can manipulate f of x and do lots of fun things. So please let me know if you have any questions about Fourier transforms or any of the topics that are involved in Fourier transforms. Euler's formula, again, you can check out the power series on how that is derived. If you have questions about how to do integrals and things like that, or if you have more questions about Fourier series or even the odd and even function shenanigans, because that is super useful to know. Cool. So take this, go forth, and math all of the things. Yay! All right, thank you for watching. If you liked these videos, please support me on Patreon, because I do these videos out of the goodness of my heart, and the more that folks help support and compensate for my time, the more videos I can do and the more complex topics like these I can dive into. Yay! So thank you so much, and we'll see you next time. Bye!